So, glad you came. Welcome to the Academy. Hopefully you figured out where everything is. Snacks out there, restrooms around the corner, out this way. So we're going to kick it off with our first student talk of the session, which is going to be George Pandya talking about the correlation between a president's approval rating and the performance of his party in midterm elections. All right, the floor is yours.
Thank you. So as he said, my name is George Pandya. I'm, as you can see from this slide, I'm in Arapahoe Community College, but I'm also high school junior at the STEM High School. I'm taking all my classes at ACC, and I'm actually going to graduate with an associate's degree in math by the end of this fall. But of course, you came to hear about this, so let's get into it. Just a bit of background about the research. Over the years, American politics have become polarized to the point that the president can't easily collaborate with the other party and pass legislation because one party generally stonewalls any legislation proposed by the other party. So because of this political landscape, it's necessary that if a president wants to be perceived as effective, he needs to pass legislation. And this is a lot easier if he has representation from his party in Congress. Now, political parties invest a lot of time and effort into making sure that first, their candidate is elected president and then is perceived as effective by passing this legislation. So this study looked at the effect of the former over the latter. Specifically, how the president's approval rating influences the number of seats won or lost in the midterm elections by the president's party. And then it sought to come up with a prediction for the 2014 midterm elections. Because I did this research last summer, actually, so the elections didn't happen. By the way, I just want to put this out that I hope that as my presentation goes on, my approval rating doesn't look like that. So the data was collected from Gallup, which collected the data since 1946. You might be wondering why 46? Well, that was the first year Gallup started archiving their approval rating data, their polling data. I also got the data for the number of seats won or lost by the parties, by the president's party in the midterm elections, just based on congressional records. I looked at four things. First, the president's party. Second, his approval rating on the eve of the midterm elections. And third, the net gain and loss of the president's party during said elections. So here's a look at the data. From here, a few things are immediately clear. First of all, if you just look over yonder about the president's approval rating, the average approval rating is 51%. Makes sense, it's about at 50%, some popular presidents, some unpopular presidents. 51%, the 51.5%, actually Gallup's margin of error is 1.5%, kind of falls in there. Standard deviation is 10, which means about 66%, 2/3 of the points are predominantly between 60 and 40%. Makes sense, you can see that there are a few points over 60, a few points under 40, but the majority of them fall in that general category. So here you have some of this represented graphically. Over on the top right, you can see the president's approval rating versus the seats gained and lost. If you look, this is interesting, I wish I had a pointer, but over there near the top is the 0, and only 2 points are actually above 0, which means there are only 2 times in history since 46 that the president's party gained seats. That was 98 with President Clinton and 2002 with President Bush. Now, I wanted to create a predictive model from this. So, of course, you can't create an exact linear model, but you can approximate it using the least squares method, where you have an equation y equals a plus bx, and your b is equal to the correlation coefficient times the standard deviation of x values over the standard deviation of the y values, and your intercept is equal to the average of the y values minus whatever you got for b times the average of the x values. Now b can further be expanded into that, which is just the sum of from 1 to the number of points. I had 17 points here. The x's times the y's minus the sum of 1 to 17 of the x's times the sum of 1 to 17 of the y's, all over the sum of 1 to 17 of the x initial minus the average squared. So, I mean not the x initial, excuse me, the x point. So I did this work, I won't get into putting all the numbers in, but I got the equation y equals 1.59x minus 107.423 with a correlation coefficient of 0.7 and an r squared, a Pearson's coefficient of 0.552 approximately. This shows a moderately strong correlation. It's of course not a full correlation, not above 0.9, but it's relatively useful. But of course, this only matters if if we do a test to make sure that this is actually statistically significant and not because of random chance. So doing a regression analysis test, I did a t-test for model utility, where the t-value on this t-curve with 17 degrees of freedom is equal to the correlation coefficient over 1 minus r squared over the number of points minus 2, which is the degrees of freedom. So here's the curve of the 15 degrees of freedom. I got a t-value of 4, which is all the way over here, about where the curve becomes indistinguishable from the axis. So you know this is going to be a small value. Now the probability value, which is the area under that curve, is 0.001, which means that you can reject the null hypothesis that it's an improper fit with about 99.9% probability. And by the way, just I forgot to go over this, the hypothesis test. I just had a null hypothesis that the line is an improper fit, and the alternative hypothesis that this is false. So the null hypothesis was proven incorrect, which means that this is a relatively proper fit, which means I can go and use this for predicting the elections. So for predicting the midterm elections on the eve of the 2014 elections, I believe it was November 3rd, 4th. In any case, President Obama had an approval rating of 44%, according to Gallup's nationwide random polling. So constructing a confidence interval, just using the formula with x being 44 plus t times the standard error of the line, is he's going to lose 37 seats with an error of 10. Now, the Democratic Party did lose 28 seats in the midterm elections, which the confidence interval was between 26.6 and 47.88. So it was within the error, it was predicted. So that was nice. It worked, which is always nice. But going back to the slide with the data, you can see with the points are a lot closer together if you look at the above 60%. So I wanted to look at specific intervals from 0 to 50% and above 60%. Oops. So first of all, looking at creating a model for the approval ratings under 50%, I did the same least squares regression approximation. Got an equation of y equals negative 275 plus 4.375x. Doing a t-test for model utility over here, I got the probability, excuse me, that was for over 50%. I don't know if I made that clear. I got a probability that the null hypothesis is false of 0.005, which means I can reject the null hypothesis that it's an improper fit with even more confidence than previously. And also the correlation coefficient is also higher, it's 0.69, whereas before it was about 0.5. So if the president's approval rating is over 50%, this is an even more accurate predictor. But what about under 50%? Now, you might be asking why I didn't use this for the 2014 elections, and this is part of the reason. I did the least squares method, and a equals negative 69 plus 0.7x, but the r-squared value is only 0.04, so very low correlation. And doing the t-test for model utility, there's a 62% chance that the null hypothesis is true, 48% chance that it's false. So you can't reject the null hypothesis, so if it's under 50%, it's not exactly an appropriate fit, but for over 50%, it does work well. So this study revealed a useful predictor model that did successfully predict the 2014 elections, and it also revealed a more useful model if the president's approval rating is more than 50%. Now, these findings also demonstrated a potential conundrum for a president's approval rating, because he'll have a much easier time passing legislation if he has a majority of his party in Congress. But until that happens, his legislation is going to be kind of stalled, and he's going to have trouble passing legislation, which will further bring down his approval rating, which could also affect how his party does in the midterms, further worsening the issue. Now, using this model, political advisors can advise their tactical doctrine going into midterm elections and work on proper strategies to ensure that they're able to effectively carry out their party's agenda and pass proper legislation. Now, to summarize this study, it came up with a useful predictor for president approval ratings in general that did predict the 2014 elections. and if the approval rating is over 50%, an even more useful predictor. Thanks all for your time, and thank you to Professor Berg for your encouragement. I'll now entertain any questions you may have. Yes?
Do you plan on moving forward, like continuing this research?
Absolutely.
Okay.
Yeah, I'm going to put in, the next step is of course to put in the 2014 results and refine the model, and then just use it for future elections as well.
Okay.
Yes?
Was it correct that President Obama's approval rating was below 50%?
Yes.
So how do you explain that it seemed to work so well when you looked at just the president's below 50% and it didn't seem to have very good correlation?
So just going back to the graph, the points were relatively more scattered for the under 50% approval ratings. So when, but using the entire model, we had more data, and I was able to come up with a more useful predictor using all the data, but using just the data under 50%, fewer points, more randomness. So
it's the linear fit to just the below 50% points.
Exactly. So it's not, there's no fit to under 50%, but in general, I was able to use the general predictor to predict the elections. I saw a question over there.
Yeah, I'm just sort of curious. I'm not sure how to frame the question, but as you go forward, could you try to quantify the association between that approval and the legislative success that he would have in terms of these, people that are below 50% only get 25% of their agenda passed, where people above might get. Are you able to do that kind of work?
Yeah, that's an interesting point. That could be another thing to look into, because you can quantify it a few ways, like how many bills were passed, or the congressional approval rating, or approval rating of government in general. But yeah, that's a good question. It certainly can be done. Yes?
I'm taking this to science fair. Seriously.
Yeah, I suppose I could. I haven't really thought of the next step. I wanted to come here and get some feedback, and I'm interested in publishing it as well.
No, I think it's an exemplar science fair project, because oftentimes it's just a percentage I win, a percentage I don't win my hypothesis. Very nice.
Sure. Thank you. Any other questions? Sure. Well, again, thanks for your time.
We could have one more round of applause for our speaker.